Hello, Mr. Gazda here. Homework, or worksheet 189, color to the core. Okay, let's color. Here you go. So on this, this is page 10 of the reference table. You probably want to tear it off so you don't have to flip back and forth as much. And this really throws a lot of people for a loop. Okay, what this shows here is a cross section, a cut through the Earth, inner core of Earth. This section is the outer core of Earth. This is what we call the stiffer mantle. This is the Asthenosphere, plastic mantle. It's kind of liquidish. That's where the plastic is. It's a big moldable, like hot plastic would be, but it is kind of liquidish. That's why you have these convection currents here, and that's the cause of plate. The cause of the plates moving, the force that drives the plates are these convection currents, the movement of this rock-like material there. And then you have, this is the lithosphere here, which are these two layers, crust, ridge, and mantle. It lists the density of those different layers here. And the key thing that really throws people for a loop, students, really drives them crazy, is the temperature part and the pressure part. So you could relate any part on the Earth here down to the pressure, and you would use this line. This line tells you the pressure at any given depth. So and the depth here, so 5,000, if you want to know at 5,000 kilometers depth what the pressure is, you'd go up to here to this line, and you'd go over, and it'd be about 3 million atmospheres. Or you could go down from here, which is 5,000, was right about here, go down there. And that really drives people crazy. Temperature as well. You want to know what the temperature is right at, let's say this boundary here, you go down here to the line and then go over, and just students have trouble seeing that. So let's just get into some of the coloring here, and let's see how we're going to do. Okay, so the first one says color the lithosphere yellow. Color the lithosphere yellow. So let me get a good yellow pencil here. Lithosphere. The lithosphere is the combination of these two layers, crust and ridge and mantle. Those two together make up the lithosphere. And the crust is the black, and the ridge and mantle is this little layer here. So I'd really kind of color this. Obviously, coloring over the black with the yellow you can't see, but you get the point. That is what the lithosphere is. That's for the first one, and hopefully you can see that. Next up is color from 2,000 to 3,000 kilometers depth into the Earth brown. Okay, we're coloring on Earth. This chart doesn't mean anything. We're coloring on this. Don't color the charts. Don't color the charts. Let me try to get a brown pencil here. Brown. This is. Let me say brown. Here we go. Brown. What am I doing? 2,000 to 3,000. So a depth of 2,000. Okay. So I'm gonna draw a line of 2,000. So I'm going to go, so it's this right here, 2,000 up to here. So 2,000 is right here on Earth, okay? And what you want to do is, realizing this is curved, I would draw my 2,000 line, I'm estimating it off here, and I'm saying this right here is about, I'm estimating again, that anywhere on this line is about 2,000 kilometers down, 2,000 down, 2,000 down, 2,000, 2,000 kilometers, okay? And then 3,000 is this line here, right up to here, and it's right below the boundary between the outer core and stiffer mantle, right there. So it's right about there, okay, right about there. I can estimate it, and then I color that brown. I'm coloring this brown, just so you get a sense of how this chart works and how the depth on Earth works. Okay, you have to have that curved nature of it. Okay, that's the second one, and then the third one, color the inner core blue. Okay, I have a little light blue here. Inner core is right here. I'm coloring it blue. Okay, notice it says iron and nickel is the inner core, iron and nickel the outer core. There you go. What else is next? 4. Find the section of inner Earth that has temperatures between 5,000 to 6,000 degrees Celsius and color that section green. Okay, so where's a good color green? So 5,000. So this can be tricky for people. So how do you do that? 5,000. This is where's it 5,000 degrees? It's right about here. And if you look, it's right at about 3,000 kilometers. So that I can go up to here. I'm going to color that right here. So that depth of 5,000 is this green right here. Okay, that's 5,000, and where's 6,000? 6,000 degrees is right 6,000 here, over to the line, right up there. Now I'm estimating, going up, 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 up to about here. If you can see that, this green isn't working so great. And then I kind of color it around like this. This is something. Let me try to get a different green. I'm having trouble with my pencils here. And I'm going to color this green right here. So this area is on Earth, and wow, this is really hard to. Hopefully you can see this in the video. But this area is an area that would be anything between 5,000 and 6,000 degrees Celsius. That's how far down you'd have to go. That many students find troubling. Hopefully that makes sense to you. And 5, color the convection currents shown blue. So the ones that are shown, you want to color them blue. Again, I'm going back to blue. Do I have a darker blue here? Darker blue, darker blue. How about this one? Darker blue. So the convection currents are here. It's these arrows show the convection. Just color over them. I want people to see what they are, know what convection currents are. And again, it's the movement here. It gets heated here, and then it will expand, less dense. It will rise, move this way. This is the driving force of the plate tectonics that moves the plates here and here. And you probably want to color over these too. This shows a section of the convection currents, kind of. That's what I was getting at when I said color over blue. Okay. Now, let's see what kind of questions we have. Put these in order of densest to least dense, and it's these layers here. So, most dense is going to be, so the densities are here. And if you look, the inner core, these are all numbers for density. So it really goes, the densest stuff is in the middle. Inner core, outer core, stiffer mantle, and then you have continental crust and oceanic crust. Okay, so that is what the order should be. So most dense is going to be inner core. All this is grams per cubic centimeter. That's important. Inner core, outer core, inner core, outer core. What do I have? I have stiffer mantle. So I have stiffer mantle, and then it is oceanic crust, and then continental crust, and continental crust is the least dense, and that's why we have where they you have convergent plate boundaries here. The ocean crust will sink down because it's more dense than the continental crust. So it's easier to float. It's more buoyant. Think of the way styrofoam is more buoyant in water. Now it's obviously not as buoyant as styrofoam. It's just, it's rock, but the ocean crust, being basalt, it does say basalt, is more dense. That's why it sinks compared to this one. When they meet, this will stay. It's kind of quote unquote floating on the asthenosphere. What is the temperature at point A? So at point A, you'd go like this. Okay, you kind of follow it down to here. Then you go down. I'm drawing it with my red pen to about here. I'm just kind of eyeing it up to about here. Then I kind of go over to here. Okay, and maybe it's 6,500. About, it's not a. That's a reason. 6,500, and you got to make sure you know what the temperature is. It's degrees Celsius. Don't just write degrees, because degrees Fahrenheit is very different. It's like half that. So that's careful. Be careful. Label these on the diagram: trench, mid-ocean ridge. Okay. And you should know that this now, where you have subduction, you're gonna have a trench here. Okay. That's where the trench is, where you have the one plate going beneath the other, which is called subduction. And then the mid-ocean ridge, this plate here is moving this way. This plate's moving this way. Lava will come up. This is going to be mid-ocean ridge. Okay, that's important to know that. 4. The boundary called a Moho is the interface between what two layers of Earth? It's in 2 layers. Now you really got to kind of look. It's not super easy to see in this diagram, but the Moho is this dashed line, and it's kind of between the dark layer and the white layer. So it's going to be the crust and ridge and mantle, what they're calling crust and ridge and mantle here. Okay, crust and rigid mantle. Alright, 5. What do we think the inner core is made of? And I wrote what do we think, meaning we scientists, and that's what's on here, because no one's ever been down there and ever seen it, but they're pretty sure iron and nickel is what the outer core is composed of. No, I'm sorry. Question says inner core. See, it's good. Good. I went back and looked at inner core, iron and nickel also. So it would be the same answer, but there's iron and nickel. 6. What is the name of the layer in which the convection currents occur? Okay, convection currents again are right here. You see them here, and it's called the asthenosphere. Asthenosphere. That's how you say it. And saying this like a plastic mantle. Asthenosphere. Okay. 7. What section of Earth is a liquid? Hint: the temperature chart on the bottom of the page. Okay, and now this is a tricky question for many students. Is it the stiffer mantle, outer core, or inner core? Okay, stiffer mantle, outer core, inner core. So, in order for a material to be liquid, it has to be hotter than its melting point. Hotter than its melting point, okay? Melting points are written here in dashed lines, okay? So, here, what you have, for instance, in the stiffer mantle, here's the temperature, here's the melting point we think that this rock would be. So the temperature is less than the melting point, so this is going to be a solid. Also, if you look at the inner core, as you follow the inner core down to here, the melting point of the inner core is here, the temperature is lower, so that is going to be a solid as well. And but you're going to see the liquid part, outer core. How can we tell from this? Well, the melting point in it, like let's say right here, melting point is here. Okay, maybe it's 4,800 C, and the actual temperature is 5,300 C. So it's hotter than the melting point, and it's liquid. Okay, so that is important. And then kids often ask, why does the melting point change? And it has a lot to do with the pressure. More pressure will change. Usually more pressure will increase the melting point. So as you get further down, you have more pressure. So then there's there's more to it than that, but on a basic level, that's the good way to look at it. How thick is the outer core of Earth? Outer core is here. The outer core is here. So how thick is it? If I was to go down, how thick is it? Well, the outer core, the dashed line's here, so it's right here and here. So it's a little less than 3,000. Maybe it begins at 2,900 kilometers, and then maybe it goes to 5,100 kilometers about, right? So that's about 2,200 kilometers, maybe 2,300, something like that, but definitely not 2,000 because it's less than 3, it's more than 5. So 2,000, too quick of an answer. 2,200 kilometers is a good answer, maybe 23, something like that, but again, not 2,000. What is the pressure at point A? Point A. So now I'm doing the pressure. If I was to do the pressure at point A, I would follow it down to, I'm going to follow down to here, okay, and then over to here. Now, I didn't do a very good job of that. Let's say it's 3.5, but it's not 3.5. 3.5. What is the units here? Well, the units are atmospheres, and these numbers are all in millions. So it's 3.5 million atmospheres. 3.5 million atmospheres. But you could write, I'm going to write it like this. I'm going to write it out, and you could write atmospheres, ATMs. 3, so that's 3.5 million times more pressure than we feel at the surface due to the air, which with the air, you don't really feel the air pressure, but it exists, so it's a little hard to really explain, but that's how you'd use the chart. This one here, what is the pressure at point B? Now check this out. Here's see, B is this far down, so to really see where B is on this chart, you got to kind of follow it along this way. Okay? And it's about there, and then go down to here, and then go down to here, and maybe it's 0.4, 0.5, something like that. So maybe you're right, 400,000, okay, or maybe even 500,000 or 600,000 atmospheres. It's not 0.4. 400,000, very different because it's a million atmospheres. A lot of people get that wrong. Don't be one of them. Look at this depth. So low depth below the surface, high depth close to the surface, going down. As you go from the surface as you go from the surface down, what happens to the density? It increases. How does that graph go? Like that. Okay? And then temperature and depth and temperature. So again, as you go down, what happens to, as you go from here to here, which in this case here to here, what happens to temperature? Temperature goes up. All right? Temperature goes up. So again, and we're just looking for a general relationship up. We don't need to see that curve, but that's what we're after. So using this page of the reference table and kind of understanding some of the basics of the core of Earth is important. So hopefully that helped for me and all the staff here at GazdaHW Productions. Thank you for watching 189.